Hello and good day. Today in Algebra, we are covering PO3, our first power objective. So this is one of the ones where when it comes to the test, you must show me that you understand this. And it is adding and subtracting rational numbers, which includes, of course, integers, decimals, and fractions. This is kind of like the grunt work of math, you know, like when you go to basketball practice, soccer practice, you always warm up with a dribbling drill or a passing drill. Things that just kind of get through them, okay, but they're so important to the game. That's this stuff here, okay? I know you've added fractions before. I know you've worked with decimals and negatives and all that stuff before, but we are getting this done, and so that we can, you know, really solidify it and use it when we get into the more complicated stuff down the road. A few things to remember though, because especially with fractions, there are always those mistakes that are consistently made, and so just want to hash them out now, get them out there, and move on. So we'll start with integers, and I'm going to scroll down here if I can do so successfully. Oh, it was so close. I was just about to say it's going to be a great day, but then okay. Yeah. Okay. So we're going to start with basically. So this table, note that it is a key point, therefore it can go on a help sheet on a test, right? So whatever you need in here, you can use. You cannot, however, use a calculator. Okay. So when you add a positive, raise your hand and tell me some of the 18 examples. Which of the 18 examples we have down below here show adding a positive number? Noah. The first one, negative 7 plus 9 is adding a positive. What's another one? Yeah. Negative 15 plus 31 is adding a positive. What's another example? Yeah. Negative 9 plus 9 is adding a positive. And I believe you see another one?
Yep. 13 minus -4.
13 minus negative 4. Okay.
And 13 minus negative 13.
Well, let's not get carried away here, because actually that is not adding a positive. Okay. Folks, 13 minus negative 4 would fall under the subtracting a negative category, which we'll talk about in just a little bit. But adding a positive are the three that are circled in red here. Okay. And even though all three of these happen to start with a negative number, what can you tell me about that sign in front of the first number as far as how it relates to the operation? What does that sign in the first number tell you about the operation that we're doing here? Luke?
That you were going to add them both.
Okay. Yeah?
That means it's basically subtracting, honestly.
Well, not quite. In fact, the number, the sign of your first number has absolutely nothing to do with the operation. The sign in the first number simply tells you where on the number line you're starting. So in this example here, negative 7 plus 9, we're starting at negative 7, and we're adding 9. Okay, so we are going to the right. The operation when you add a positive is addition, and we are going to the right. An example of that, either of these three would work, but we'll just take negative 7 plus 9. What is the value of negative 7 plus 9?
2.
Positive 2. Okay. Positive 2. Can you not see because of the angle, or?
Well, I also I have glasses. But I can't see them because when I wear a mask, they fog off.
Glasses problems. I understand completely. You made us have to figure out a way to. Yeah. We can talk about moving you later on, but for right now you might just have to suffer through it. Okay. 3, 2, 1. You are quiet. So adding a positive, addition, going to the right on the number line. In this case, the example of that would be 2. The next type is going to be adding a negative. Oh my goodness. Whoa, I don't. Oh man. Yeah, no, you don't have to. It's just. I'm just rewriting the first line on the table here. Okay, so the next one here would be adding a negative. And raise your hand if you can tell me what in the 18 examples here would be an example of adding a negative. Gabe? 14 plus negative 3 is adding a negative. Another one, yeah, Noah.
12 plus negative 15.
12 plus negative 15. Luke?
Negative 25 plus.
Negative 25 plus negative 8. Again, we see here, that sign of that first number makes no difference. Look what's in between. In between 14 and 3 is plus negative. In between negative 25 and 8 is plus negative. That's where the operation is, what's in between the numbers. Nothing to do with that first sign. Any others in here as well? I don't think so.
Yeah.
Where?
Oh.
I don't think so.
No?
Yeah.
Continue.
So the operation when we add a negative actually is what? Subtraction. So when we add a negative, we are going to the left on the number line. Example we'll take, just the first one here, 14 plus negative 3. What's the value of 14 plus negative 3? Anybody? 11. Okay.
11.
We are adding a negative, so we are subtracting. 14 plus negative 3 is really the same thing as 14 minus 3. And so we get 11 as a value. Matthew, do you have a question? Okay, then let's raise our hand if we want to say something. The next one, the third one. Subtracting a positive. Which of these 18 here show subtracting a positive? Linnea? 5 minus 3. Okay. You've seen that before, right? Alan?
14 minus 6.
14 minus 6. 0 minus 4. Any others? What? Negative 13 minus 6. Because, again, that sign of that first number has nothing to do with the operation. You're looking between here. Okay? That's why your hands are up. Yep. Yeah. Negative 7 minus 19. Sebastian? Negative 42 minus 17. I think that's going to be about 12 minus 20. And that's it there. Okay? But again, right, I put so many of that type on here because I really want you to see, that sign of that first number, nothing to do with the operation. It's what's in between. So we are subtracting when we subtract a positive, which means we go to the left on the number line. An example, let's take this negative 13 minus 6. What is the value of negative 13 minus 6? Negative 13 minus 6, yeah. Negative 19. We're starting at negative 13. We are subtracting 6, or moving 6 to the left on the number line, and we end at negative 19. The last type is subtracting a negative. Give me an example of subtracting a negative from the 18 that we have here. Matthew.
13 minus negative 4.
13 minus negative 4 is subtracting a negative. Luke.
Negative 4 minus negative 5.
Negative 4 minus negative 5. Noah.
Negative 22 minus negative 28.
Negative
Positive 22.
yes, positive 22 minus negative 18. Hamden. 13 minus negative 13. I see another one here. Negative 5 minus negative 20. What's the difference? Because these two get messed up all the time. What's the difference between something like 22 minus negative 18 and negative 13 minus 6? Because they both have two negative signs, right? But they're different. How? Nick?
The negative, or 22 minus negative 18, there's two negative signs right next to each other.
Right.
While in negative 13 minus 6, there's a number in between.
These two negative signs both affect the operation because they are, looks kind of like a face, both affect the operation because they are between the numbers. Whereas in negative 13 minus 6, that first sign doesn't make a difference. We only care about that sign between the 13 and the 6. So what operation does that become when we subtract a negative? 22 minus negative 18. Olivia? It is addition. For you lit people, short for literature, slang, yeah. When you have a double negative in a sentence, what actually happens? Yeah, if you're not happy, like I'm not happy, well, it means you are happy. Okay, same kind of thing happens here. Those two signs back to back like that end up canceling out essentially and turn it into the operation of addition, which means that when we see this on the number line, we're going to the right. So 22 minus negative 18, we'll use that as our example. 22 minus negative 18, what's the value of that? Matthew? 40. So if it helps you to kind of go through each of these things here and make the change, 13 minus negative 4, that's the same thing as 13 plus 4. Negative 4 minus negative 5, that's the same thing as negative 4 plus 5. If it helps you to go through that and identify and make those changes, that might be helpful for you. Okay? Any questions on integers? As long as you remember that the first number tells you where on the number line you're starting, and then what's in between identifies the operation and which direction you go, you should be fine. Yes?
I checked for the last one is if there are two negatives in the other parentheses, if you kind of look at it closely, kind of looks like an addition sign.
Sure. If you want to just kind of superimpose a plus here, kind of connect, negative 5 plus 20. That works out well. Yeah?
How do you want us to show it?
There really isn't any work to be shown for this one, but decimals and fractions is where it'll come up, where you can show some work. Yes.
So when we answer, we just have to put the answer
Yes.
and then check it in my calculator.
Right. And remember, you will not be able to use a calculator on this test. So if you're using a calculator to find the answer here, you're really not doing yourself any good.
Not even to check the answer?
You can check, right, on the test, you won't be able to use it to check it. So no calculators out for anything
Just for this test or?
for this first test.
Oh, perfect.
Okay? Because this is the test where I'm testing your ability to calculate. In future tests, the focus will be on something else that will use calculations, but the emphasis is on something else, so you can use a calculator for that. Let's scroll down to decimals. Who can tell me what is the thing to remember when adding and subtracting decimals? Where if you are teaching decimals to someone for the first time, you say, make sure you remember this. Luke?
And if there's multiple ones, like in the 100 or 1,000 or 1,000, you have to have zeros on your decimal.
More so for comparing decimals, where that comes in handy. But you might want to do that. I'm thinking of something that's kind of even more critical than filling in empty placeholders with zeros. McKenna? Yes, the place values matter. You would not put 7.1 and 12.6 and add those together, right? Because you'd be adding tenths with wholes. That doesn't work out well. Ones with tens. That doesn't work out well. Line up the decimals. So you've got place values lined up. 7.1, 12.6, and then you can add vertically with your carrying or subtract vertically with your borrowing or whatever. Okay? 19.7, we get there. But I want to talk about that third one over there. Negative 3.65 minus 14.12. Who'd like to chime in and kind of give us your thought process for calculating something like that, where you're starting negative, then you're subtracting. Negative 3.65 minus 14.12. Yeah.
I feel like it'd just be like adding two negatives together.
Okay. So how would you go about doing it?
Put the 3 first. I'd probably just add it like it was a positive and then just put the negative sign at the end.
Yeah. If you're starting negative and you're going further negative. I mean, let's just kind of take a look at this one on a number line here. Here's 0. Negative 3.65 will be about there. Okay, that's where we're starting. And we're subtracting 14.12, so we're going to the left by that amount, and we'll end up at, I believe it's negative 17.77, right? That's kind of a visualization of what's going on here. Isn't that pretty much the same thing as starting at positive 3.65 and going further away from 0 to the right, adding 14.12? In both cases, you're starting the same distance away from 0, 3.65, and you're going 14.12 further. So if in your mind, you want to think about this as, okay, 3.65 plus 14.12 is positive 17.77, but because I'm starting at negative 3.65 and subtracting 14.12, my answer is actually going to be negative 17.77. There's actually a lot more similar about the two sides of 0, positive and negative numbers, than there is different. If you're starting a certain distance away from 0 and continuing away from 0, it's really the same thing whether you're on positive or negative, right? Things only get kind of tricky when you cross over 0, when you change signs. That's when things tend to get a little more complicated. Yeah, Griff. Oh, okay. Yes. No. You're playing with a water ball, not hand up. All right. Very good. Any questions on that?
That's not good.
Okay. Any other questions on decimals? I think the others should be pretty straightforward, pretty self-explanatory. Just line them up, do your adding, do your subtracting. Okay. The third type, everybody's favorite, we saved the best for last. That is fractions. And what is the thing? Well, there's really a couple things, but what is a thing that we've just got to remember when we add and subtract fractions? Where if we don't remember this, we are dooming ourselves. Colin?
We have to make a common denominator.
Those denominators have to be the same when we add or subtract. Okay? Can anybody tell me why? I mean, every math teacher that you've ever had that's talked to you about fractions has told you that, right? Why is that a requirement? Why is that a requirement? Well, go get it. Luke.
Because it's really hard to do it if it's like 7 and 13, because you wouldn't have the same common, like you wouldn't have the same bottom. So how would you make the tops the same?
And why do we need that, though? Why do we need those common denominators? Why can't we just add 7 and 13 to get 20? Nothing to do with signs. Olivia?
Because you can't add the denominators together.
Why not? Life would be so much easier if we could. Why did they make the rule that you can't?
I don't know.
Well, what does the denominator of a fraction tell you about the whole? Okay, that fraction bar means division. What the denominator does is it gives you a sense of the size of the piece of the whole, right? 2/12 and 7/6. Those 12ths and 6ths are different sizes, okay? And really what the denominator does is it describes like a thing, a size of an object like a thing. So it would be just as correct, rather than 2/12 plus 7/6, it'd be just as correct to say we are taking 2 chairs and adding 7 tables, right? You can't add chairs and tables together. What we get here, 9 chables? No. Exactly.
That's way too many
Okay.
tables for 2 chairs.
If my son, when he grows up, he wants to be a zoologist. He wants to own his own zoo. Now to him, growing up is being 7 years old and riding his bike to a zoo that he owns. But I don't want to crush the kid's dreams, but so we'll see what happens there. But anyway, if you owned a zoo and you got 2 new pandas, you would not put them with 7 lions, would you?
They would like fight.
That would be a terrible result. Okay? These things got to be the same when we combine them. So what the way this one's written, we can either get a common denominator of We can either get a common denominator of 6 by reducing the first fraction, or we can get a common denominator of 12 by manipulating the second one. What would you rather do? Do you want to go for 12ths? We can manipulate. So we're going to keep the 2 12ths the same, and we're going to multiply both 7 and 6 by 2 to get 14 12ths, and now we can add them because the denominators are the same. However, what's that second caveat to adding or subtracting fractions involving the denominators that we must remember? Sebastian?
You have to simplify them when you're done.
When you're all done, certainly, but we're not even there yet. We haven't even added them yet. Catherine? Right. The denominators must be the same and they stay the same, which makes sense because, if you're adding 2 lions to 14 lions, you don't get 16 mega lions or super lions, right? No, they're still just lions. Okay? The whatever you add, those 12ths are still just 12ths. So denominators must be the same. Don't add pandas and lions together, and they stay the same. We don't need mega lions running around. Maybe that's how they got murder hornets over back around the summer. Someone didn't keep their denominators the same. Okay?
But what about the mega jacks?
The mega, that's a whole other story. So now, as Sebastian said, we do need to simplify. Just like how you would never ask your lit teacher. So, Mrs. Chalmers, for this essay that you want me to write, do you want me to end sentences with punctuation, periods, question marks? Is that something? No. Never ask me if you should simplify your fractions. The answer is always yes. It's just what we do. Okay? It's just what we do. So divide both 16 and 12 by 4, and we get 4/3 as a simplified answer. If you would like to write that as a mixed number, 1 1/3, be my guest. Although I will tell you that as you get further into the maths, you will use improper fractions more and more, and mixed numbers less and less. So even though both values are correct, get in that habit, or just don't be surprised if you see more improper fractions going forward. Okay. Any of those 7 remaining ones that you want to talk about because they're slightly intimidating or look like so much fun, you want to share the experience with all of us? Matthew.
Can you show how to do it when there's a mixed number?
Sure. Let's look at 2 5/9 minus 1 9/10. So there is a shortcut for converting a mixed number to an improper fraction. Who can remind us what the shortcut is? Griff?
So it'll be 9 times 2 plus 5.
Sure. You multiply the denominator by the whole and then add that numerator. So 9 times 2 is 18, plus 5 is 23, and we would get 23/9. Question? Okay. Save that for this later. Who can tell me why that works? No. Not. It's mathgic. Mathic. I don't know. Mathic. What's the math behind the math here, Colin? Why does that work?
Because when you have it in an improper fraction form like that, they just simplify it into the mixed number.
Okay, we can go back to the mixed number, right? 9 goes into 23 2 whole times with 5 left over. That's how we get 2 5/9. But this shortcut, I mean, why does that work? That's what I'm looking for here. Why does that shortcut work? Luke?
Because that number had to go into 9 2 separate times for it to work like that.
Okay. I think you're on the right track. How many ninths make one whole?
9.
How many ninths make one whole? 9. So really what we have going on here, for us to have two wholes, we have one whole of 9/9 plus a second whole of 9/9 plus the fraction of 5/9. And if we combine all that together, 9 plus 9 plus 5 is 23. And then we have our denominator of 9. So those two wholes that we have out in front here are really just, 9/9 plus 9/9, or 1 plus 1. Okay? McKenna, you had your hand up.
Another way you could do it is keep the whole numbers off, and then like subtract 2 minus 1, so you would have 1, and then change, then you would just have the fractions like that.
You have to be careful if the number you're subtracting is larger than the fraction that you have here. 5/9 minus 9/10. You just have to account for that. That is another method to use, but there's some caveats you got to kind of watch out for. It's important to know why things work when we use shortcuts. There are some things in life that you don't need to care why it works. Like I don't need to know. I don't care why when I push buttons on my phone, someone else answers from 25 miles away. It just works, and that's really great for me. But the math behind these shortcuts, these are the important things. Okay. Any others you would like to discuss? Any others you want to go over? All right, on your plate for tonight, if you are staying for geometry, you know what to do with that. We start at 1:45, we go until 2:45. Con is due tonight. Math packet, if you want me to check it over beforehand, needs to be turned in tomorrow. And then your homework for this is to finish the page PO3, and you've got some time to work on it here. So that is how you math.